Well, first off, just thank you so much for having me. I am so excited to be here. Presenting here today on accessibility really makes me feel like my career has come full circle. A fun fact about me is that Android was not my chosen career path. It's just something that I ended up in after a bank hired me as a technologist with literally no experience. And I will say that I'm very happy with where I ended up doing something that I'm at least okay at and that I really enjoy doing. And if I look back at that team, my first task was being told to work on with all these accessibility experts and fix these bugs in the app to make it more accessible. When I think back to that, I'm like, oof, I probably should not have entrusted something so important to essentially a child who barely knew how to use an Android device at the time. But I'm also so thankful that this is how I started my career, that I had the opportunity to learn so much about mobile accessibility, excuse me, right out of the gate, and then I got to learn best practices and work with experts. And I've been able to carry that knowledge with me throughout my mobile career. So being here today at an Android conference talking about mobile accessibility is kind of special for me. And I also think that now is a really great time to get started learning about accessibility, although I'll give the caveat that I don't think this is a bad time to get started learning about accessibility. Because right now we're going through a shift in the entire Android community and going towards Jetpack Compose. And so everyone is out here learning how to implement these new accessibility features together, including me. And there's a lot of really great content coming out from folks in the community and from Google as well, focused on this and how to do it in Jetpack Compose. Today, I'm going to talk about both XML solutions and Jetpack Compose solutions in the hopes of showing you how your solutions from XML might port into Jetpack Compose, because doing that has been a really important mental model for me, is how things in XML map into Jetpack Compose, but also so that you can get started supporting accessibility regardless of the current state of your project, which may or may not include Jetpack Compose. Before we get started, I just want to give everyone the opportunity, if you would prefer to have these slides and follow along locally, you can get them as Google Slides from bit.ly/roboto-doc, or as a PDF on GitHub, bit.ly/roboto-pdf. These will be available after the talk as well. So the first thing that you should know about me is that I care a lot about making the world a more accessible and inclusive place. And for me, that means that I care a lot about making the tech space itself more accessible to more people, particularly people who have been historically excluded from tech, like women and other underrepresented groups. This is why I try to be really involved in organizations like Women Who Code and other tech organizations who focus on making tech more diverse, inclusive, and equitable, and lend my support and expertise where and when appropriate. Second, I want to use my expertise to build products that are more inclusive and accessible. There's a lot of ways to build inclusive and accessible products. Today, we're going to talk about some of the tools built into the Android framework to very technically and programmatically build more accessible apps for physical limitations some folks might experience. But your path to building inclusive technology should not stop there. There's a lot more to think about when designing and building inclusive experiences. Inclusive apps might also mean looking at imagery in your app to see if your graphics only show a particular gender or race, or looking at your copy to make sure that it doesn't perpetuate stereotypes or is inclusive of folks with different pronouns. At the end of the day, I really think that these two goals go hand in hand, because when you have a more diverse and inclusive team, then you can build better, more inclusive, accessible products. However, I find that accessibility is often swept under the rug or put off because it's seen as a nice to have and not a need to have. So I want to get started by discussing some of the reasons that accessibility is so important to include from the beginning. It can have very real impacts on your team financially, your number of users, legally, and more. So let's jump in. First, building an accessible app means that more users can use your app. Nearly 1 in 4 people have some kind of disability. And if you do the math on the 2 billion Android users worldwide, that means that 50 million Android users have some kind of disability. Not only that, but a survey also found that folks are willing to spend more money if they can access your product easier. They're willing to pay for accessibility features, although in my opinion, they should not have to. This also means that it can affect your bottom line to have those users included in your user base. Next, in the words of Kim Creighton, the anti-racist economist, lack of inclusion is the risk and crisis management issue. In 2019, Domino's lost a court case when a man with vision impairment sued the pizza chain after he was unable to order food on the Domino's website and mobile app, despite using screen reader technology. This ruling said that the website and mobile app are public spaces and must adhere to ADA compliance. And so while this is not a particularly fun reason, it is all too often the reasons that companies do start doing the work to build accessible applications. Next, building accessible apps is better for everyone. There are many accessibility features that I, for one, just take for granted, and it's easy to forget why those features were originally built. The number one that comes to mind is quickly tabbing through forms without ever moving my hand and trying to use a mouse. But there's also even more simpler examples like using camel case when attaching hashtags. Camel case makes it a lot easier for me, an able-bodied person, to read and understand those, and it also makes it easier for screen reader technologies to understand how to interpret those hashtags. There's also examples, very physical examples, like the dips and sidewalks when you're at the airport or on the curbs downtown. It's really easy to think about, oh yes, of course that makes sense. There's luggage at airports, but in reality, again, this is a feature that was built for accessibility that has real-world benefits for the rest of us as well. And finally, it's the right thing to do. This time, quoting Tatiana Mack, a web developer, teacher, and activist, compassionate action is better than empathy. Adding accessibility support to your applications is a very concrete action that you as a developer can take to make the world a better place. And to summarize, particularly given that I am here today at Chicago Roboto speaking about accessibility in front of someone that I really look up to in the mobile accessibility space, I wanted to give Victoria a shout out. Accessibility is not only a nice thing to do, but your app quality increases as you make it more accessible. It's the right thing to do, and it makes your app better for more users and also for all of your users. So let's start with a general high-level discussion of the types of disabilities or impairments that you or your users might experience. And remember that there's a range for all of these. First, we can talk about mobility impairments, which could range from using a wheelchair to having shaking hands. Users with motor impairments may use hardware devices, like an accessibility switch, to control your app or accessibility menu. There are also cognitive impairments. Cognitive impairments can range from dyslexia to cerebral palsy. Folks with these kinds of impairments may use action blocks to set up routines for things that they often do so they can access them easier. For visual impairments, we have a range from color blindness to complete blindness. And so folks with vision impairments may increase the size of their text before they interact with your app, use a Braille keyboard, or use TalkBack to have your app talk out loud or be read out loud. And finally, deaf and hard of hearing. Folks with this impairment may use closed captioning, live transcribe, or live captioning to better understand the material that your app is presenting. This is just a small overview of the types of disabilities and how your user may use features of the operating system to interact with your app. Folks can experience one or any number of these, and they can also use one or any number of these different accessibility features to interact with your app in the easiest way for them. You can also find more accessibility settings if you open your app settings that folks might be using on their device. It's also important to note that able-bodied users might also face similar challenges under specific circumstances. Not all impairments will be lifelong or permanent, and some might be temporary given the situation. An example for me is that I really like staying up late, notably too late, too much of the time. And so I very often use subtitles and closed captionings so that I don't wake up my partner while I'm watching TV late into the morning. So what are the web content accessibility guidelines, and why do they matter for mobile? This is a set of guidelines meant for improving web accessibility and produced by the World Wide Web Consortium. The most recent version was published in 2018. They describe 3 different tiers of accessibility. A is the basic level of accessibility access. AA tries to address the biggest and most common barriers for users with disability. And AAA is significant improvements and often complex improvements to making the web more accessible. The reason that they matter for mobile is because they aren't tied to a specific framework. Instead, they're designed around principles and not technology. And so they can be applied to frameworks like mobile based around these certain principles. The 4 principles that the Web Content Accessibility Guidelines are built around are perceivable, operable, understandable, and robust. In general, level A is the target because it's not always possible to reach double A. But it's also important to remember that once you reach double A, your work is not done. There's still more improvements that you can make, even if you cannot make it to that triple A level. When you think about the accessibility guidelines and those 4 principles, I think that they can be summarized in mobile as providing a consistent experience. If the app behaves in a way that the accessibility framework expects it to behave, then it should be perceivable, operable, understandable, and robust. There's a lot of really intense and wild things that you can do with defining custom accessibility actions and announcements and controlling the focus of your app, but you shouldn't have to most of the time. Google provides developers a lot of APIs to implement consistent accessibility practices through your apps, including custom apps. And so if you're not often using those, then you probably want to step back and consider why you're doing what you're doing, and if you can meet those, if your app can be described by those principles. Building a consistent app experience does not mean that you cannot build a beautiful custom application, but only that you have to follow best practices as you do it. And again, it does mean that your app experience will be better for everyone. New users will be able to quickly become familiar with how to make the most of your application if it follows patterns that they already recognize from other apps on their phone. We're going to start by talking a little bit about how to test your application before we talk about how to make the changes necessary to build an accessible application. The reason that we're looking at testing first is because we need to know how to find out the problem areas in our application before we're necessarily able to fix them. This is especially important if you're new to building accessible applications and don't always know all the common pitfalls that you might find in your application. The first way to test a product for accessibility is you. It's for you to manually test the app with the tools that folks with disabilities or impairments might also use. It also lets you become familiar with the challenges that they might face. We talked about some of the different tools that folks might be using in the beginning. We were talking about the different types of disabilities. It's important for you to become familiar with these tools and experience your app from that perspective. You can be the first line of defense in finding places where other people might struggle to finish a task within your app. Just like we do user accessibility testing to test new features or UIs, to make sure that the folks that are using our app enjoy our app. We can also do user testing to make sure our app is accessible. User testing is when we get feedback from real people who use the application. And then finally, there are also accessibility experts, like the ones that I got to work with at the beginning of my career, who can come in and evaluate your application. However, if you have nothing implementing, starting with manual testing will likely only lead to frustration. And so it may make sense to start with some of the automated tools that can help you to fix the low-hanging fruit before you jump in and find user pain points as they go through your flow. Although nothing will replace feedback from actual people, there are some really good tools available that can help you build accessible apps from the start so that you're at a really good place when it's time to start manually testing. There are several accessibility scanning apps on the App Store. In this presentation, we'll talk about using the Accessibility Scanner. Accessibility Scanner is an app by Google available on the Play Store that scans your app and offers suggestions to improve the accessibility of your app. They also have a whole suite of other accessibility tools you can also install from the App Store. UI Automator Viewer provides a convenient GUI for scanning and analyzing the UI components currently displayed on your device. And this can help you build UI tests to test accessibility and also debug when you have some problems. And finally, Android Studio will show lit warnings for various accessibility issues. You can also build accessibility checks into your UI tests using Espresso or Roboelectric. You can configure and enable accessibility testing using accessibility checks class and using either framework. The accessibility scanner is going to scan your current application and provide suggestions to improve accessibility of your app based on content labels, touch target sizes, clickable items, and text and image contrast. After installing it, you can find in the accessibility menu in your settings, Once you're ready to start using the accessibility scanner, it will ask you to allow some permissions. These permissions are essential to using the scanner and allows the app to draw over the other applications to provide you details about the accessibility of that app. So let's quickly see how it works. I built a very, very rough application. And if you think, that's a really ugly UI, you're correct. But it was built out specifically so that the accessibility scanner catches some different things during its scan. It wouldn't be very helpful to build out a beautiful application with all the accessibility features already built in and then show you that nothing comes back. So if we open this app, we have a very simple app that has a username, a repository, and it can fetch all the commits. And so what we're going to do to run the accessibility scan is click on the checkbox that will show up after enabling it. And you have an option between recording or taking a snapshot. And so in this case, I'm going to take a snapshot of the current screen. It'll prepare the results and then give me suggestions based on what it thinks I could be doing better. And so in this case, we see the username, the repository, a clear button, and the bottom button. If I click into one of these, it can give me more details about what the suggestion is and why I might consider making the change, and more information about why it's important in both the implementation and the design. And so I can go through all the different suggestions to find out not only what I need to do to update it, but also why it's important to make those changes. It's important to remember that the accessibility scanner is a really good first step for building accessible apps, but it's also not perfect. For example, it can only check what's currently on the screen, and so you have to think about all the different states that your app could be in. This is three screenshots of this particular app in 3 different states, and you see in different images, I get a different number of results and different things highlighted. There are some things that it can always pick up on, like the fact that my two text field edit text are both too small for the touch target size, and similarly that the button in the bottom right does not have a content label and is also too small. But there are things that it picks up sometimes and not others. For example, the fetch commit buttons and both the left and the right image have the same color and background, but when I only changed the text color of the button itself and left the background as is, it did not notice that that contrast is not the correct ratio. Whereas when I set the background color of the button and the text color on the far right image, it could pick that up. This is also going to give us some high-level topics that we're going to talk about in more depth, including touch target size, color contrast, labels, some of the accessibility APIs, and text size. So question, does the scanner app work for apps written in Compose? I was actually moderately worried about it, that it would not, because the accessibility framework is so tightly coupled with the view hierarchy and view classes. This is where it gets a lot of the information about how the view should behave. But I was happily and pleasantly surprised that in fact it does work with a Compose application and can get really similar results. And so this UI was built to kind of mimic the other UI, but written in Jetpack Compose. And we see in this case, we have 2 suggestions on the clear and fetch commit buttons. And again, I can zoom in on either of those suggestions to find out more about what I need to update and why it's important. So now let's jump in and talk about solving some of these accessibility suggestions. So the first thing that we're going to talk about is touch targets. Your app's UI is easier to use if it uses controls that are easy to see and easy to tap. This is yet another good example of how building an accessible UI is better for everyone. I can get really, really frustrated when it takes multiple tries to perform an action because the button's too small and my fingers can't quite hit it. The recommended size for each interactive UI element, focusable area specifically, or touch target size is at least 48 by 48. However, this does not mean that the visible area has to be 48 by 48. And this also means as well that you as a developer can quietly implement that all your touch sizes are 48 by 48 without talking to your designer about changing their icon sizes. You can achieve these touch target size either by combining padding, height or width on either side, or you can also do it by using the min height and min width. If you're unfamiliar with min height and mid width, all you need to know is that they essentially automatically add the extra padding that you need to a UI element to make it meet whatever minimum requirement you have set. Using min height and min width can build a flexible and accessible UI. So when considering which one to use, whether to use a minimum height and minimum width or a height and width, how are you going to make those kind of decisions when building your UI? It can be really important to use the min height and the min width with wrap content instead of explicitly setting those parameters, because we want our height and width to be flexible. What if it's on a small device and that text ends up needing to wrap around to a different line? What if it's translated into another language and the text just ends up being longer? Or what if they change their text size? By using wrap content in combination with the min height, it allows our UI element to expand to the size needed if that text size does need to change. Also, it's important to note that we actually can't assume that Android elements will necessarily adhere to our needs out of the box. We just noticed that our edit texts were highlighted in our accessibility scan, and this is because edit texts are actually not the correct height out of the box, and so we do need to set those heights explicitly. In this case, because I do want those texts to wrap around if necessary, I'm going to use a minimum height of 48 and then just set my layout height to wrap content. In this case, I also don't need to set a minimum width because I just let it fill up the entire size of the screen, so there's nowhere for that to extend. On the other hand, we can consider looking at an image view. And so on our application, we have the image view in the lower right-hand corner. And so in this case, instead of the icon will never change size. So in this case, I can set the actual height and the actual width and then add the padding that I need. And so instead of having my height and width set to a hard code at 40, I update that to 48 by 48 so that it meets my requirements, and then add whatever kind of padding I need to return it to its original UI state. So now let's talk about what this is going to look like in Compose. In Compose, we can use modifiers to achieve the same effect. First, on our text field, for the user to input their username and repository, we would again want to set a minimum height. And so we can do this using the height in modifier extension function. This function takes two arguments, minimum and maximum, but in the case of these dynamic text, we only want to set the minimum because we want the text to grow as it's needed and don't want to set a maximum value it can extend to. Similarly to the last slide, we also don't need to set a min max width, but they are also available for you. Again, in the case of an image that won't change in size, we can also set the size directly and then add padding modifier to give us our intended UI effect. Remember that the order of modifier functions is significant. Since each function makes changes to the modifier returned by the previous function, the sequence affects the final result. In this case, we apply the padding before setting the size and after applying the clickable modifier. This way, the padding will be added to the size and the whole element will be clickable. You can achieve the same results by first setting the size to the total size that you want, so 48 dp, and then applying the extra padding that you want as well. I think that this way is a little bit more intuitive compared to XML Android, but again, it's up to you and there are multiple ways to achieve the same thing. Another simple change is ensuring that you meet color contrast ratio requirements. AA compliance requires at least a 4.5 to 1 ratio for regular text and 3 to 1 for large text. On this slide, there's examples of 7.62 to 1, 3.92 to 1, and 2.38 to 1. So you get kind of a feel for what those different ratios kind of look like. The material design is a design system that Google developed to help developers create beautiful and intuitive UIs. And one of the tools that they provide is the material color palette. This is important to know because often a lot of apps are very themed with specific colors that they want to be using. And by using this color palette, you're able to pick lighter shades or darker shades that will meet those accessibility requirements, but stay inside your color family. And there's also a lot of tools that can check to help you meet if your UI meets AA compliance. Linked in this slide is the tool that I usually use to check if our background colors and foreground colors meet those requirements. In general, in my experience, the accessibility scanner is pretty good at finding color contrast issues. And the programmatic fix for meeting these color contrast recommendations is just updating your text and image colors or your background, which is straightforward in both XML and Compose most of the time. Next, we want to talk a little bit about labels. In theory, adding labels should be fairly straightforward, but in practice, it can be tricky at times. The basics of adding a label is that each UI element in your app includes a description that describes the element's purpose. In Android, we do this using the content description, although for some views, we get this out of the box for free. For example, a text view, Android accessibility can automatically pull some information from that text view and give you a description. Some things to keep in mind when you're thinking about how to write your labels is using the correct UI element in your view. Also, don't include the UI element in the description because the accessibility framework will do that automatically for you. And that description should be unique so that there's no confusion of where they are on your screen at any given time. And you should skip over decorative effects. You also need to think about localization. You don't want your app to only be accessible in one country. You want your descriptions to be concise because you have to remember that people have to navigate through your application and listen to all these descriptions as they go through the screen to find the information that they want. And that it should be descriptive and tell them exactly what that element does and why it's there. And so there is a lot to think about with labels. And so as any good senior developer will tell you, does it need a label? The answer is always, it depends. But generally, here are some guidelines for things to think about. Text views, in general, most of the time, no. Edit text, you need some kind of label to let them know what should go in that field. Images, in general, yes. Or image buttons that have actions, in general, yes. Image views, maybe. And text buttons, also generally no. Some of the things to think about when you're deciding if something in your UI does need a label is, can it be skipped? Is it a decorator? Should it be grouped together? Does this information make more sense together? And how will it be read? Does it include numbers or abbreviations that the accessibility talkback features might not understand? It's also important to use the right element. And there's a lot of reasons to do this beyond accessibility. It gives you more out of the box as a developer. When we use the right element, we get a lot for free, and not just with regards to labels. For buttons, for example, in classic XML, by default, it will give you some styling that is helpful for your buttons. It will give you the right accent colors and button colors for different button states. It can add some elevation to make it obvious that it's clickable, and it'll also put all your text in caps. And when the button is read, it will automatically append that UI label to the end. In Compose, on the other hand, buttons are more flexible, but also have a couple of gotchas. For example, by default, the Jetpack Compose button has a minimum height of 36 instead of 48. And we already saw earlier that when we did that accessibility scan, both buttons were flagged as needing larger touch targets. And so now you know why. You also don't get all the styling for the font right out of the box. However, Jetpack Compose does give you the flexibility to create some very complex button elements and other UI elements. The final argument of a button is content, which is just another composable, which means that you can very easily build complex custom button composables while maintaining that base UI element. Funny enough, the size of an icon button is actually correctly set to 48 by 48. And there's a small to-do over the button icon size in the source code that says, investigate our strategy around accessibility touch targets and remove per component definitions of this size. And so it sounds like it is on the roadmap to update some of those other touch target size as well. Clickable elements in your app by default don't provide very much information about what that clickable element does. Therefore, the accessibility services like TalkBack will give a very generic default description. For a button, you might recognize this as double click to activate. In Compose, you are also able to set the clickable action by setting on click label. So now if we go back to our edit text, something that was marked in our accessibility scan, we have our username and edit box in our repository and repository edit text. We want to talk about how we might be able to label these in our XML. In this case, we have two different options. First, we can use label for. And so we see that on the left-hand side that the top text view has label for and then is assigned to the ID of our edit text below. This label for pairs together elements where one describes the other. On the other hand, we could also use hint. And so that goes directly on the edit text, and we can set hint to a string, again, from our string file, so that can be easily localized. And the hint is an example of a valid input and is available to the screen reader. We do not want to use label and hint together because each UI element should have only a single label to describe its contents. So if we think about the app that we looked at before, we have a list and it has about 30 items. Out of the box, TalkBack will read each recycler view item as one continuous label and include the position. There might be some times that we don't want this to always happen, and so we can also control which elements are really important to the screen reader as well. And so if I had a more complex recycler view, noting of course that mine is very simple and that it probably makes sense for all of that information to be read at once, the commit message, author, and date. But if I wanted to explicitly call out one specific element of my recycler view as important that the user should be able to interact with, I can use the screen reader focusable XML attribute and set that equal to true. It is worth keeping in mind that it's important to think about why that's important, because that could up to double the time that it takes for someone to navigate through a list of items. Next, there might be times when you're not in a recycler view, but it actually makes sense for things to be grouped together. By default, most different elements are going to be read separately. In this case, we can explicitly set focusable to false on some of our items inside of our container, and then set screen reader focusable true on the outside constraint layout. This, for example, might be a really great idea if you were displaying speaker information in a list or in an app, and you wanted it to read my name, my company, and my job title all at once, because those are all relevant informations that don't need to be read separately. And finally, sometimes you want a combination of all of these. For example, if you're considering something like a calendar view that might have different days and then different views inside those different days, it might be relevant to label the container itself that represents the day and also read each individual item inside that container as well. In this case, we can just add the screen reader focusable set to true on our containers and leave everything inside that container as is, and it will continue to read through those. So now let's look at Jetpack Compose for the same kind of situations. So in some composables, we have access to the content description directly, things like image composables and icon composables. This is a really nice feature of Jetpack Compose because it forces developers to think about including content description as they write their program instead of as an afterthought. If we think about adding an image view to our XML, then we don't include a content label, there are lint rules, as we mentioned earlier, set up that will give you a warning if you're missing something like a content description. However, it can be too easy to ignore warnings, especially compared to a required argument. We also notice that the content description is a nullable string in Jetpack Compose. Like we talked about earlier, every image does not necessarily need a description. And so setting the content description to null is the right thing to do in some cases where the image only serves as decoration. If we think about our text view in Jetpack Compose, then we have similar features to what we had with our edit text in XML. In this case, we have the option of setting a placeholder, and the placeholder is like our hint. It will just show up in our text field when there's no input already available. And so again, much like buttons, you can actually set this as a composable, and so you have a lot of flexibility with how to display that information. Similarly to the label for, you can also do a label, and this will actually serve as both a hint and the label on the field. And so when there's no information and you're not focused on your text field, it will display itself as a hint inside the text field. But as you click on it or when you fill it out, it moves above, much like a label that we saw earlier. Again, similar to edit text, if you set both the placeholder and the label, you might end up with some unexpected or unwanted behavior. The label will take precedence in this situation, and so it will display the label when the text field is empty, but it will read both your label and then your placeholder text back to back when TalkBack hits that UI element. Which one you decide to use is going to depend on what you want your UI to look like as a final product. But what do we do for these situations that we don't have direct access to our content description, or it's not an edit text that explicitly describes a label and placeholder? In Jetpack Compose, Compose uses semantic properties to pass information to the accessibility service. Semantic properties provide information about UI elements that are displayed to the user. Much like height and width, the semantic properties are added in the modifier. When we mentioned that you don't generally need to add a content description for text views, this is also generally true for text composables, because these composables can actually fill out those semantic properties with information it can infer from the composable function. When you look at the semantics modifier extension function, you have two arguments: merge descendants and properties. These semantic properties can do a lot, and we don't have time to talk about them all today, but I wanted to call out some of them, and also this slide does not include a complete list. I also recommend going through and looking at all the available semantic properties and the descriptions of when and where they should be used. It can give you a really good feel for things you should be considering when you're building accessible applications. So some of these properties include the content description. And so through the semantics modifier, you can add a content description to anything, and you're not limited to only things that have a content description in the function parameters. We also have a heading, which, much like the web, you can mark certain areas of your text as headings so that users can more quickly navigate to that content. They have things like live region. This handles something that updates the UI and needs to be read as those updates happen. If you did the Android Dev Challenge and built a countdown timer, this might have been a good use for it. We also have roles in semantics and Jetpack Compose. We already talked a little bit about how important it is to use the correct UI element to build our views, because choosing those elements helps the accessibility framework infer the semantic properties it needs. In traditional Android, this information is pulled from the class, which we again mentioned earlier when I talked about how I was worried the scanner wouldn't work because the accessibility features are tied so closely to the class system. With a role semantic property, we can tell Android how a composable should behave. Some of the roles include buttons, checkbox, switch, radio button, tab, and image. And then we'll talk about a couple more of these semantic properties in the next couple of slides. Much like in XML, we can also combine our views in a similar way. Because of the way that I built out the Jetpack Compose UI, I was actually reading each individual thing in my list of items individually. And so for each element in my list, I would read first the commit message, then the author, and then the date. And so they had to swipe 3 times to get through one element. Instead, I can now set this merge descendants equals true, and then that gives me more like a recycler view behavior where all of those are read together. Similarly to when we talked about the calendar example, we can also set a content description in our container, like our column, and then also set nothing special on our text views inside. And so then it will read the container itself, and then separately each individual element. And so we know that there are a lot of tools to help us build accessible UIs. On XML side, we talked about label for the screen or focusable, and we also have things like the accessibility heading. And then on the Jetpack Compose, we have all of these different semantic properties. I also want to call out one of my favorite helper class, which is the TTS span, which is a special type of span that can pass in metadata to give contextual information about the string. This information can help text-to-speech correctly pronounce a text element. In this example, I have the number 1, 2, 3, 4, 5, 6, 7, 8, 9, and if I did not specifically pass it in as a TTS span with the type digit, this will be read out as 123,456,789. By using this TTS span, I can then have TalkBack read it back as 1, 2, 3, 4, 5, 6, 7, 8, 9. This would have been really helpful to know about when I was working at the bank and doing a lot with addresses. If I think about what my current address would be, how it would be read out as O, because I live in Ohio, 45,044, which would not be a super helpful way to recognize my own address. The TTS span also has supports for things like dates, digits, and phone numbers, electronic amounts, and other things, which are really common elements in applications. So what are the other things that we have to think about? Now that we've talked about some of these base features, we can talk about the different types of ways for you to display your app, custom views and the accessibility APIs, and other media. When we think about these different displays, some of the things that you can consider is what will happen to your application if they change their text to large. We already talked about building really flexible text elements by using min height and min width instead of setting things to a specific height. Personally, I like to keep my smallest phone on the largest text setting, because I know that if I can build a UI that fits inside that, then it will fit on most phones in the market. This is also a really good way to test your app in general for all the available screen sizes that might be out there in Android, and see how your application stretches and condenses in those different phone screen sizes. Again, making an app better for everyone to use. Similarly, dark mode is also an accessibility feature. I feel like it's often stereotypical for people like me, developers in our tech crowd, but by building this out, you're going to please those and also have access to another accessibility feature inside your application. I also want to quickly touch on some of the accessibility APIs that you can use in your custom views. When you think about building custom views, the best practice is to extend from the view element that you most closely relate to. I think in the Android documentation, they give the example of trying to build out a 3-option toggle, and so extending from toggle so that you automatically get all the accessibility features of the toggle. Although that is very helpful, it's not always going to solve your problems, and so there are also these accessibility APIs that can help add accessibility features. And so for this first example, swipe to delete is a very common pattern, and so we can add that extra accessibility option by using the view compact add accessibility action onto our specific view. In this case, it would be the mail cell. Add the string for what the action would be. In this case, it'd be something for remove, and then what action it should be performing. Similarly, there are APIs for adding accessibility clickable support for spans that don't include links and may include other things that you again just pass in your view. And also accessibility APIs for telling Android how your view should act in comparison to other views. So if you wanted to build a custom alert and not extend from the dialog class, you can then use a set accessibility pane title to let Android know that your accessibility view should behave much like other alerts. And again, these also port over to Jetpack Compose as well. And so in our semantics modifier, we can set our pane title equal to alert title, and this will let it know that that particular view should act a lot like an alert. Or we can add custom actions by inside our semantics modifier. There's a custom actions, and you can add on a list of actions that show both the label for that action and the action itself. If you include other types of media in your application, it's also important to think about how users might be able to interact with those. And so you should include controls that allow users to pause and stop their media, change the volume, and toggle on subtitles, as well as skip the media altogether and find that information elsewhere in the application. And finally, testing. How will you test your app for your accessibility features now that they're implemented? Both Espresso and RoboElectric support accessibility testing incorporate with other UI tests. These accessibility check testing frameworks checks for things like missing or incorrect labels, small touch target size, low contrast, and other implementation-specific issues. It's similar to the accessibility scanner, and it just tries to flag things that won't send the expected values to the accessibility framework. As you interact with these in your test, these accessibility checks will run automatically before proceeding. So if you're interacting with a button, for example, it will check for the button and around the button for any accessibility issues. If you're using Espresso for UI testing, you can use accessibility checks.enable to enable the checks, and the result will be the accessibility validator. You also have some options for how to customize this. For example, you can tell it to run from the root view so that it will test more UI elements in your screen. And you can also suppress different matchers so that you can go back and fix those and while your tests are still passing. It's important to note that you have to actually use a view action and not just directly access the view for it to be affected by these accessibility checks. Similarly, in RoboElectric, you can use @accessibility checks to achieve similar results. Although notably, RoboElectric has some known issues in the framework, and so it's important to not let this be the only way that you're testing for the accessibility of your app. In Compose, on the other hand, UI tests use the semantics to interact with the UI hierarchy. And since we just talked about how these semantics framework is primarily used for accessibility, your test can take advantage of the information that you have decided as the developer to expose and write tests that explicitly test some of your accessibility features. And finally, with that, what's next on your journey to building accessible products? The web content accessibility guidelines are set to be updated sometime in 2021, which we are currently in. And draft 1 was published in late January and continues to have updates, so you can check those out. Where do I learn more? Again, shout out to Victoria, who wrote a literal book on Android accessibility by tutorials, which is available on raywunderlich.com, and I cannot recommend it more. And if you're just getting started with accessibility and Compose, where should you look next? I recommend going to Android Compose Accessibility. They have an entire section dedicated to it. And they also just released in the last couple of days a new code lab that will go through a lot of these and give you hands-on experience implementing these kinds of features. And with that, I just want to thank you all for having me here again. If you're interested in chatting with me after the conference, you can find me on Twitter, _Sierra O'Brien, or also there's a whole host of ways to get in touch with me on my website, sierraobrien.dev.
Thank you so much. That talk was incredibly informative, and I learned wonderful things that I am definitely going to be bringing back with me. For everyone watching, if you have questions for Sierra, you can join the Android for Everyone Accessibility in Android Slack channel. We do have one question right now that we can answer quick before going to a break. Is there a way to encode spans such as TTS hints you mentioned inside string resources? Splitting up string resources and manually adding the span elements in code could make localization a bit of a nightmare.
Yes, I have, the short answer is yes. And I don't know who to ask it because I closed Slack down because I don't want the notification. It makes me nervous, but I can chat with you afterwards if you want more information about that. All of my links are included in string resources using like CData, a pattern, and whatever extra HTML that I need. And then I send it at the last minute through the HTML from HTML function or something like that. I'm sorry, I don't know all the function names off the top of my head. So that those strings can be localized pretty simply with the full context of everything that you need to know about it, which I do think helps a lot with building accessible and localization strings that make sense, is seeing the full context of what that string will be doing.